In section 1.3, we're going to discuss how we can make new functions from old functions. Now, there's two different ways that we're going to approach this. Now that we have this catalog of functions that we discussed from the previous section, this basic catalog of functions that we're familiar with, first, how can we quickly make a graph of that function with some minor changes in the numbers? And to do this, we're going to review what are called transformations of functions. So in some cases when you make just these minor changes, you're just kind of either shifting, reflecting, or stretching this basic graph to create the new one. So you don't need to get out your calculator or get out a computer and some software to figure out what this looks like. You can just quickly sort of shuffle things around with these transformations. And then the second way we're going to approach this is through this other sort of prompt here. So how can we take some of the functions from our new catalog and combine them to create new functions? So kind of from an algebraic standpoint. And what is the domain and range of that new function going to be in that case? Okay, so let's start with transformations. That'll be the first half of this section that we're going to get through. So given the graph of a function, again, suppose this is one of the functions from our basic catalog of functions that we discussed in the previous section. We can obtain a new graph by performing the following transformations. So the first group here is called vertical and horizontal shifts. So how can we vertically and horizontally shift things? Well, if you take the function and you add or subtract a constant on the end, or if you add or subtract a constant inside, this is acting inside of the function on the x values. Those are two different ways you can shift things. Now, the first case, when you were just adding onto the end of the function or subtracting, you're going to be going up or down depending on whether you're adding a positive number or you're subtracting a positive number. It's going to go either up or down. It's going to go left or right if you add or subtract inside. Now here's the tricky part about what's happening inside of the function. Things are going to act kind of counterintuitively here. So if you're subtracting c and c is positive, you're actually going to go to the right by c units. If you're adding c and c is positive, then it's going to be going to the left. So it acts opposite when you're doing things inside of the function, and it acts the way you think it would act if it's outside of the function. Okay, next we'll talk about vertical and horizontal stretching and reflecting. So again, suppose that we have a positive constant, but more specifically here, suppose that our constant is bigger than 1. Okay, so what about this stretching and reflecting? So just like before, if you're acting outside of the function here, if we're multiplying by c, or multiplying by 1 over c, excuse me, then you're either going to stretch or shrink vertically, and it's going to act the way you think it would act. So for example, if you're multiplying, let's say by 2, the function, you're going to stretch it vertically by that factor. Whereas if you multiply by a half, you're going to shrink it by that factor. Now if it's acting inside of the function, it's going to be acting directly on the x's, and things act, again, counterintuitively. If it's c times x and c is bigger than 1, it's going to shrink things. Because rather than multiplying the x values by c, we're actually going to be dividing them. And if you're dividing by c, it's going to end up multiplying by c, the x's. And then we have the two different types of reflections that we'll be talking about here. The first is x-axis reflection. This is kind of easy to remember if you look at a graph. So let's look at a graph here. So suppose you have some point or some coordinate, xy. Okay, so what happens with xy? What happens to reflect things over the x-axis? What do you have to do to this coordinate? Well, you have to change the signs of the y's. Well, that's what this is doing. If you put a minus sign out front of the function, that's changing the signs on the y's, because remember, f of x represents y. So you're changing the signs of the y's, and then that's going to reflect over the x-axis. So that's the first type of reflection, that x-axis reflection. The y-axis reflection is if we change the signs of the x's instead. Change the signs of the x's, that's going to reflect it over the y-axis. Maybe I should get this correct here. So this would be negative x, y, whereas if we change the sign here, that would be negative y. There we go. Okay, so this is how you change the function in order to produce that result. Either the x-axis reflection, if the minus is outside, or a y-axis reflection, if the minus is on the inside of the function, acting directly on the x's. Okay, and then there's a nice graph, couple graphs here, a couple figures that I got from the textbook here. So given the graph of y equals f of x, the figure below shows the various translations on the same axes. So if this is the original function, if we add c or subtract c, that's going to either shift us up if c is positive, up or down. And again, if we add or subtract c inside of the function, it's going to shift us left or right, and it's kind of counterintuitive. It's opposite of what we would think. And then we have the stretches and shrinks over here, or I guess stretching and reflecting. So the reflecting we already talked about here, but the stretching and shrinking vertically is if you're multiplying by c outside, depending on whether c is bigger than 1, or if what you're multiplying by is basically less than 1, then it's going to sort of be shrinking things here. Now, one thing that's important here with transformations is that the transformations that are inside of the function, which act on the x values, act in an opposite way than we would expect. On the other hand, transformations outside of the function, which act on the y values, act in the way that you would expect. So that's what we've already talked about. The order of the transformations is going to be important as well. And the way that we're going to do this is we're going to prepare the function and then do the transformations from left to right. We'll talk about what that means here in a minute. Another thing to observe here is that x and y transformations are independent of one another. So if we're shifting vertically and stretching horizontally, for example, those two things act independent from one another. So it's really only important to get the separate x and y transformations done in the proper order. Now let's talk about that in a little bit more detail here. Why is the order so important? So suppose we wanted to sketch the graph of this rapidly by picking out a basic function and then just kind of moving that basic function around quickly. So suppose we had minus 2 over x plus 1. Well, the basic function that you would pick out is just the reciprocal function, 1 over x, and this is what its graph looks like right here. So we have a plot of its graph. So notice that we have 3 transformations here. So first, we have this vertical shift. Then we have this reflection. And since this is 2 here, we're sort of vertically stretching things as well. So there's a vertical stretch, there's a reflection, and there's, to be specific, there's a, you're changing the signs of the y's, which reflects over the x-axis, and then there's a vertical shift. Now, all 3 of these are acting on the y's. So what happens if you do them in the wrong order? What happens if you just wanted to do the vertical shift first? You saw that first, you did it first. So you vertically shift things. Then you do the reflection and the vertical stretch, and then here's what you would end up with. On the other hand, this is what you should get. If you just type this into your graphing calculator, or if you type it into, say, Wolfram Alpha or Desmos, this is what you should get. Let's compare the two on the same screen here. So notice that if you did the incorrect order, this is what you'd get on the left, and if you did the correct order, you get the one on the right. Now, they do have the same basic shape. You kind of have this swoop over here on the left, swoop over here on the left, this swoop over here on the right, swoop over here on the right. But what if this graph, the correct one here, was supposed to represent, I don't know, something where you just have a positive or 0 value, money, or time or any number of things. Then your graph went from making sense, it makes sense for x bigger than or equal to 2, whereas it doesn't make sense at all here on the left. So this can be very important just in applications, sort of getting this correct. Okay, we're going to go ahead and stop here with this video just so that it doesn't get too terribly long here. In the next video, we're going to pick up with how we can actually go through this process ourselves. Now that we know what those basic transformations are, we're going to start with a basic function and try to start with a graph of that basic function and just simply move it around by doing these transformations as a quick way of going through this.